Good morning. I am Viswanath, Assistant Professor, Department of EEE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today, I am going to discuss about nodal analysis, which is one of the reduction technique, network reduction technique in electrical circuits. Before going to nodal analysis, we need to recollect the concept of Kirchhoff's current law. Kirchhoff's current law, by the definition, is the algebraic sum of currents meeting at a point is equal to 0. Or we can say it another way as the sum of incoming currents is equal to sum of outgoing currents, and this is analogous to a physical system of water pipes. Here Q1 is the pipe which is having a inlet, and Q2, Q3 and Q4, these are outlets. The sum of the water content which is entering from the pipe Q1 is dispersed through all these three pipes. That is, physically you can say it as the amount of water entering from Q1 is equal to the amount of water which is flowing out from all the remaining three water pipes, that is Q2, Q3 and Q4. So this is Kirchhoff's current law. The statement here is the algebraic sum of currents entering a node is 0, or the sum of currents entering a node is equal to the sum of currents leaving that particular node, and this is mathematically represented as sigma n is equal to 1 to n, in is equal to 0. Pictorial representation of this Kirchhoff's law can be represented as, here it is one node. The currents which are entering are I1 is one current which is entering, and I3 is another current which is entering into that node, and I4 is the current which is entering at the same node. So sum of all these three currents, that is I1, I3 and I4, is equal to sum of the currents which are leaving, that is I5 and then I2. This is Kirchhoff's current law. So we need to recollect these parameters also. What is meant by branch, what is a node, and then loop. Branch represents a single element that may be either active element or passive element, resistor or voltage source or current source, anyone. And node is the point of interconnection between the two branches. Here we can say 5 ohms is one resistor which is connected between two nodes A and then B. So A and B are together known as two nodes, and the element which is connected between A and B, 5 ohms, is said to be one branch. And loop is a closed path. Here this is the closed path starting from node A, 5 ohms, 2 ohms and then again 10 volts. This is one closed loop, and this is another closed loop, and this is also another closed loop. Coming to the main concept, today's concept, node voltage analysis. It involves the application of Kirchhoff's current law equations instead of KVL. Kirchhoff's voltage law we are going to use in mesh analysis. And second point is one of the nodes in a given circuit is taken as a reference, which is assumed to be at ground potential. The other names for this node are datum node or ground node. And that node selection is where the maximum number of branches are connected is to be selected as the reference node, and the reference node is assumed to be at zero potential or ground potential. So next one is the potentials of all the other nodes. That is, if we assume to be n number of nodes in a given circuit, one node is said to be or assumed to be as a reference node. So the remaining nodes, that is n minus 1 number of nodes, are expressed as compared to the reference node. That is, potentials of all other nodes are defined with respect to reference node. And for all the nodes, KCL equations are written except for reference node. And the third one is the equations what we written are in terms of variables, and we need to solve to get node voltages of these equations. Next one is after obtaining the node voltages, we can get either current or voltage. That is, current flowing through any branch and voltage at any particular point of the network can be calculated after getting these nodal voltages. This is the procedure. First one is potentials of all the other nodes are assumed, that is defined with respect to reference node. Let us say it has some V1, V2 and then V3 like this. How many number of nodes are there except reference node? We are assuming those voltages as V1, V2 and V3, and then KCL equations are written for each and every node except a reference node, and we need to solve these equations to obtain that nodal voltages, and finally we can get the response in any element, that is either current or voltage. So this is the process to obtain or apply the nodal voltage analysis. So let us practice a simple problem. For the given circuit, calculate current flowing through 12 ohms and 4 ohms using the node voltage method. Here we have 60 volts voltage source, 7 ohms and then 12 ohms and then 4 ohms. We need to calculate current flowing through 12 ohms and then 4 ohms using node voltage analysis. So first point is to obtain or to assume the reference node. This is the reference node here because the three elements are going to be connected. One is 60 volts and 12 ohms and then 4 ohms. Maximum number of elements are connected at one point so that it is selected as reference node. And the another node is here. We are assuming here one node 1. So we have two nodes. One is node 1, named it as node 1, and second one node 2. So by applying Kirchhoff's current law equations, the algebraic sum of currents at a given node is 0. So we are assuming all the currents are away, that is flowing away from this node. One is I1, which is flowing through 12 ohms, and current which is flowing through I2 is from the node 1, and the current which is flowing from the same node is I3. So sum of all these currents is equal to 0. There is no incoming currents. So I1 is the current and V1 is the potential assumed to be present at that point, that is node 1. So V1 divided by 12 is the current flowing through this 12 ohms. Potential is V1, and here reference node potential is 0. So it is V1 by 12 plus V1 minus 60. We are connected positive potential to the positive potential. When we need to add the two potentials, two dissimilar ends are to be joined. If we join these two similar potentials, the potential is going to be subtractive. So here the same concept is applied here. V1 is the highest potential, assuming V1 minus 60 divided by 7 plus next one is V1 divided by 4 volts, that is current flowing through 4 ohms. So sum of these three currents is equal to 0. By rearranging all these equations, all these parameters, that is V1 is to be obtained as 18 volts. We need to calculate current flowing through these two elements, that is 12 ohms and then 4 ohms. So once we calculate the node voltage V1, current flowing through 12 ohms, current flowing through 12 volts is V1 divided by 12 and current flowing through 4 ohms is V1 divided by 4 and current flowing through these 7 ohms is V1 minus 60 divided by 7. So here the remaining currents are, one is I1 is voltage obtained is V1 divided by 12 ohms. V1 is 18 volts divided by 12. So this is the current flowing through 12 ohms and current flowing through 4 ohms. That is current flowing through 4 ohms is assumed to be I3 here. That is V1 divided by 4. So V1 here is 18 volts divided by 4. So this is the another current. So let us implement with another source. That is here we are considering two sources, 42 volts and then 10 volts. The problem here is in the circuit shown in figure, determine all branch currents by node analysis. We need to calculate all the branch currents. Currents flowing through 8 ohms, 6 ohms and 4 ohms. So by applying the nodal analysis, first we are assuming this as reference node and the another node is this one, that is, let us say this is node 1 and voltage present at this node is V1. So applying KCL to this node, V1 minus 42 divided by 8 ohms plus all the currents are assumed to be here flowing away from this node. We are assuming all the currents are flowing away from this node. So V1 minus 42 divided by 8, first one, and V1 divided by 4, second one, and V1 plus 10. That is, here the polarity connected is negative polarity is connected to positive polarity. So we need to add these two potentials. V1 plus 10 divided by 6 is equal to 0. So by rearranging this, V1 is in common with the parameters 0.125, 0.25 and 0.127, and second one is, next step is 0.5416 into V1 is equal 3.58. So we can get V1 as 6.61 volts. So after calculating the voltage V1, we can obtain the branch currents. The branch current which is flowing through 8 ohms is 42. That is, current is flowing. We are assuming the direction of current as flowing away from this node. But actually V1 obtained is 6.61. V1 here is less than 42 volts. So the direction of current is, actual direction of current is flowing in opposite direction as that of what we assumed. That is IA, that is current flowing through 8 ohms is 42 minus V1, that is 6.61 divided by 8. So current is 4.42 amperes and current flowing through 6 ohms. Current flowing through 6 ohms is V1 plus 10, that is 6.61 plus 10 divided by 6, it is 2.77 amperes, and current flowing through 4 ohms is V1 divided by 4, that is 1.65 amperes. The problem here is solved depending on the polarities connected, either positive polarity is connected to positive polarity or negative polarity is connected to positive polarity. That is, either polarities are in added condition, polarities are we are adding or we are subtracting. Based on that, the equation is going to be changed. Based on that equations written, the answer is also going to be changed. So let us consider this circuit. That is, in the given circuit, determine all the branch currents and the voltage across 5 ohms by the nodal analysis. So here this is assumed to be V1 by applying KCL equations. V1 minus 50, polarity, positive polarity is connected to positive polarity. So V1 minus 50 divided by 3 plus 6. This is one node and this is assumed to be a reference node. So V1 minus 50 divided by 2 resistors are there in this path, that is, this is the total path. V1 minus 50 divided by 3 plus 6, first term, and next one is V1 minus 25, positive polarity is again connected to positive polarity. So the two are in subtractive condition, that is V1 minus 25 divided by 2 and 8. Two resistors are connected in this path, and the last one is current which is flowing through 5 ohms. All currents are assuming, we are assuming always for the sake of simplicity, currents are leaving from this node. So sum is equal to 0. V1 minus 50 divided by 3 plus 6 is the two resistors, and V1 minus 25 divided by 2 plus 8 and V1 divided by 5. Sum of all these currents is equal to 0. So V1 is assumed to be, is obtained as 19.59 volts. So after getting the value of voltage V1, we can calculate the current flowing through all these resistors. Currents flowing through all these resistors. One is V1, current flowing through 3 and 6 is V1 minus 50 divided by 3 plus 6, which is equal to minus 3.37 amperes. That is, negative sign here indicates the direction of current which is flowing in opposite direction what we assumed. Assumed direction is like this and the actual direction of current is in opposite direction. So we are getting the answer as negative values, that is minus 3.37 amperes. And current flowing through 2 and 8 ohms. Current flowing through 2 and 8 ohms, assumed direction is this one. So it is V1 minus 25 divided by 2 plus 8. So it is 19.59 minus 25 divided by 2 plus 8. Here also we are getting the value of current as minus 0.541 amperes. And current flowing through 5 ohms. Current flowing through 5 ohms is V1 divided by reference node. Voltage is always assumed to be 0, which is at ground potential. So it is 8.056 divided by 5. So it is 3.918 amperes. And voltage across 5 ohms. Voltage across 5 ohms is 3.918 multiplied by 5 is 19.59 volts. So here we are going to consider two different sources. Previously we considered, see, in this circuit we are considering two sources, 50 volts and 25 volts voltage sources. Both are voltage sources. And in previous problem also we considered two voltage sources, 42 and then 10 volts. Now we are going to consider one voltage source and then one current source. 10 volts is the voltage source and 2 amps is the current source. So one voltage source and one current source. So determine all the branch currents and voltage across 5 ohms. All the branch currents along with voltage across 5 ohm resistor by using a nodal analysis. So by applying nodal analysis at node V1, so it is V1, voltage at this point is assumed to be V1, V1 minus 10 divided by 1 and V1 divided by 5 and V1 minus V2. Here voltage is assumed to be 2, and this is the reference node. This is reference node. So 3 currents we are assuming, 1, 2 and then 3. 3 currents are leaving from this node. V1 minus 10 divided by 1 and V1 minus 0 divided by 5, and the last one is V1 minus V2 divided by 2 is equal to 0. By simplifying this equation, we will get equation as 1.7 V1 minus 0.5 V2 is equal to 10, and applying the KCL equations at node 2. This is node 1 and this is node 2. So V2 divided by 10, V2 minus 0 divided by 10, and V2 minus V1, current flowing through here. After writing the nodal equations of first node, to write equations of second node, it is the direction of currents again assumed to be flowing outwards or away from this node. V2 minus V1 divided by 2, and the last one is assumed direction is flowing away from this node, but the actual direction of current is flowing inwards. So we need to replace that number with a negative sign, that is minus 2 is equal to 0. So the equation comes to be minus 0.5 V1 plus 0.6 V2. So two equations with two variables, that is V1 and then V2. By solving these equations, we will get V1 as 9.09 volts and then V2 10.91 volts. After obtaining these values of nodal voltages, we can calculate branch currents and then voltage across 5 ohms. Branch current is current flowing through 1 ohms. Let us say current flowing through 1 ohms is V1 divided by, current flowing through this branch is V1 divided by 1. So V1 is obtained as 9.09. Directly comes out to be 9.09 amperes. And current flowing through 5 ohms. Current flowing through 5 ohms is V1 divided by 5 ohms is the resistor. So it is V1 9.09 divided by 5, and this is the value of current. And the next one is current flowing through 2 ohms. Current flowing through 2 ohms is V1 minus V2 divided by 2 ohms. So why it is V1 minus V2 is two voltages are present here at node 1 and then at node 2. So it is V1 minus V2. That is current is flowing from V1, that is node 1 to node 2. If we assume the direction of current as node 1 to node 2, then it is V1 minus V2 divided by 2. And similarly, we can calculate current flowing through 10 ohms. That is current flowing through 10 ohms is V2 divided by 10, that is 1.091 amperes. So by obtaining these branch currents, we can calculate voltage across the 5 ohms, that is voltage across 5 ohms is current multiplied by resistance of that element. So by improving some more complexity to this nodal analysis, consider this circuit. Here it is one current source only present, but the number of loops are more. That is, previously we consider only 2 loops. Now it is 3 number of loops. So applying a nodal voltage analysis to this circuit, first assume the reference node as this one, and the remaining nodes. One is V1, V2 and then V3. These 3 are pointed out to be as 3 nodes, and node voltages are V1, V2 and then V3. So writing the nodal equations for node 1, it is V1 minus V2 divided by 5. First term V1 minus V2 divided by 5, and the second term is V1 minus V3, that is current which is flowing in this direction. Current is flowing in this direction from 1 to 2, 1 to 3, V1 minus V3 divided by 20 and V1 divided by 10, that is current which is flowing from node 1 to reference or ground node. So writing all these terms, that is including all these three currents, it is obtained as V1 7V1 minus 4V2 minus V3 is equal to 0. Equation with three variables V1, V2 and then V3, and applying node voltage at node 2, that is V2 minus V1, V2 minus V1 divided by 5 and V2 minus V3, V2 minus V3 divided by 10, and here we have one current source, that is 10 amperes. Assumed direction is in this way and actual direction of current is in opposite direction. So it is written as minus 10. So after simplifying this equation with three variables minus 2V1 plus 3V2 minus V3 is equal to 0. And nodal voltage at the third node, that is V3 minus V1, to write nodal equations at this point. Again, the node currents are assumed to be flowing away from this node. V3 minus V1, V3 minus V1 divided by 20 and V3 minus V2 divided by 10. Current which is flowing from node 2 to node 1 and current which is flowing from node 3 to reference node is V3 divided by 5. So it is equal to 0. Simplifying this equation, we obtain it as minus V1 minus 2V2 plus 7V3 is equal to 0. Three equations with three variables. After solving these three variables, we will obtain V1 as 45.45 volts and V2 as 72.73 volts and V3. So after obtaining all these voltages, we can calculate the remaining response, that is current which is flowing through all these elements. So try another problem, that is 20 volts is the voltage source and 4 amps is the current source. Find the current flowing through 20 ohms. Find the current flowing through 20 ohms is the question. To obtain this value, we need to calculate the voltage which is present at this point and the voltage which is present at this point. So assume to this node is assumed to be reference node. By writing the equations, V1 and this is V2, voltages are assumed first. V1 minus 20 divided by 5, first term, and V1 divided by 10, the second one. Currents are always assumed to be flowing out of or away from this branch or node is equal to 0. So it is obtained as 4V1 minus 40 is equal to V2. We will get a relation between V1 and V2 as this one. V2 is equal to 4V1 minus 40 and the second node is applied with Kirchhoff's current law equation, that is current is flowing 4 amps into this node, but we are assuming the direction of currents as leaving from this node. One current is leaving in this way, another current and another current. Three currents are leaving from this node. So actual direction and assumed direction both are in opposite direction. So it is written as negative sign, that is minus 4, and V2 divided by 20 and V2 minus V1 divided by 10. So simplifying this, we will obtain it as 3V2 minus V1 is equal to 80. By solving these two equations, we obtain as V1 and then V2. After getting the values of V1 and V2, current flowing through 2 ohms. Current flowing through 2 ohms is voltage V2 divided by current resistor value is 20. So V2 obtained as 40 and then resistor value is 20. So we obtain the value of current as 2 amperes. So another type of problem here is considering two current sources. Previously we calculated nodal voltages when two voltage sources are present and when one voltage source and one current source is present, and now it is considered two current sources. Another type of problem. So calculate all the node voltages, assuming this one as a reference node, or it is itself given in the problem, and 5 volts, that is 5 amperes is the current flowing in this way, is equal to V1 minus V2. The potentials are given in the problem itself, that is V1 and then V2, and reference node is also given. So we need to substitute directly in KCL equations. So currents at this point is, one is current flowing from the source 5 amperes, and the second current is flowing from V1 to V2, and third current is flowing from V1 to ground potential or zero potential point. So 5 amperes is equal to V1 minus V2 divided by 4, and V1 minus 0 divided by 2. So 3V1 minus V2 is equal to 20 is one equation, and at this node current entering at this node is 10 amperes. Current entering at this point is 10 amperes, and the current leaving from this node is V2 minus 0, V2 minus 6, V2 minus 0 divided by 6, and 5 amperes is the current leaving from this node. So totally here 4 number of currents. One is 10 amps is the entering current, and 5 amps is leaving current, and V2 minus V4, V2 minus V1 divided by 4 and plus 10. This is current flowing in this direction. So totally 4 number of currents with 2 equations, that is 2 variables, 3V1 plus 5V2 is equal to 60. By solving these equations, we will obtain V1 as 13.33 volts and V2 as 20 volts. So solve another type of similar problem. Current source, 2 current sources are present here. One is 6 amperes and second one is 3 amperes. Node voltages are specified as V1 and then V2. So current direction here is assumed to be minus V1, that is current direction is assumed to be like this, minus V1 divided by 10 minus V1 by 5, the same current, the two currents are meeting here. This is our assumption. Based on our assumption, we are writing the KCL equations is equal to sum of the two currents leaving. Two currents leaving are, one is 6 amperes and second one is V1 minus V2 divided by 2 amperes. Two currents leaving currents are here, 6 amperes and V1 minus V2 divided by 2, and the entering currents are 0 minus V1 divided by 10. Similarly, 0 minus V1 divided by 5. Based on our assumption, we are writing the equations. Accordingly, the polarities are going to be changed. That is, minus 8V1 plus 5V2 is equation 1. And similarly, at equation at node 2, it is V2 divided by 4. That is, direction of current here is assumed to be flowing from V2 to ground potential. So V2 by 4 is equal to current which is entering is 3 amperes. 3 amperes is the current entering. Similarly, 6 amperes is also the current entering one. And the third one, that is due to difference of potentials between V1 and V2 is also entering. So, the sum of three currents, one is 3 and second one is 6 and then third one is V1 minus V2 by 2 is equal to V2 divided by 4. So that is the second equation. Equation with two variables V1 and then V2. We can solve these two equations as one is V1 is 0 and V2 is 12 volts. So here solve for V1 in the given circuit. Directly the value of voltage at this node is specified as V1 and two voltage sources are present. One is 10 volts and second one is 20 volts. In a given problem, sometimes the values of nodal voltages are specified, or we need to assume the values of nodal voltages as V1, V2 and then V3. If in the problem itself it is specified as voltages like this V1, V2 or V3, we need to follow that notation only. One is the node here, assume node is here, V1 minus 10, that is voltage source is V1 minus 10 and current is here flowing in two paths. One is through 10 ohms and second one is through 5 ohms. So we can write the two separate terms, V1 minus 10 divided by 5 and V1 minus 10 divided by 10, as we have two number of currents. And the third one is, actually these two are the single branch currents, the current which is flowing from this node. And another current is V1 divided by 10 and the third one is V1 minus 20 divided by 4. So this is equal to 0. The value of V1 is obtained as 12.308 volts. So this is the given question in this problem. Find the value of V1 by applying a node voltage analysis. So with this we conclude this session on node voltage analysis. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.